Hello, welcome to another class with Mathemasoft. In today's class, we'll be looking at predicting the values of a quadratic root. In the previous class, we have discussed the nature of a quadratic root. That is, will the roots be imaginary or real, equal or unequal? And we were able to do that using our discriminants, which is represented as what? D of the values b squared minus 4ac. We basically look at 5 different conditions or 5 different situations where we have what? Different values for d based on either d equals to 0, either d is greater than 0, either d is greater than 0 and a perfect square, either d is greater than 0 and not a perfect square, or either d is less than 0. In these 5 different categories, we're able to look at how we can predict the nature of the quadratic roots. If they will be real and equal in the case of d equals to 0, if they will be real and unequal in the case of d greater than 0, if they will be real, unequal, and also rational in the case of d greater than 0 and a perfect square, and if they will be real, unequal, and irrational in the case of d being greater than 0 and not a perfect square. And lastly, if they will be imaginary and unequal, existing as a conjugate pair in the case of d less than 0. Now, in this class, we want to look at how we can easily predict values of roots for some quadratic equations. So let's get started. We already understand that ax squared plus bx plus c equals to 0 remains the general form of a quadratic equation. That is, any equation that can be expressed in this form is a quadratic equation. So the first condition I want us to look at is when c is equals to 0. What happens, or what is the clue you may actually derive when the value of c is actually 0 in a quadratic equation? So let's rewrite this and see what happens. So if c is equals to 0, ax squared plus bx plus c equals to 0, and then since this c is now 0, we have ax squared plus bx equals to 0. Then we'll see that what? X comes out, and then we have ax plus b equals 0. And then we can say x equals to 0 or ax plus b equals 0, x equals to 0 or x equals minus b over a. So whenever the constant of a quadratic equation, which is c, is equals to 0, we can say that one of the roots will be 0 and the other roots will be minus b over a. This is what you can actually decide at a glance, especially when you're writing an examination where you do not have to waste your time. So let's write this now. When c equals to 0, one of the roots, okay, equals 0 and the other equals minus b over a. This is what you can easily put right here. And this is not just formed by merely guessing. I've actually shown you now the proving. It means that what? One of the value will be what? 0. and the other will be minus b over a. So this can actually be helpful for you when you are writing an examination or when you are into competition. You can easily what? Get your answer. So the other one I want to show you, which is the second one, that can help us to predict the values of a quadratic root, is when b equals to 0 and c equals to 0 in a quadratic equation. So let's write that and see what happens. Ax squared plus bx plus c equals 0. Then since b is 0, c is also 0, what we will have left will be ax squared. Of course, 0 times x will have gone 0, and this will be what? 0. So you can say x squared equals to 0 over a, okay? And then that gives us x squared equals to what? 0. So you can have x equals to plus or minus what? Root 0, okay? X equals to what? 0 twice. So in this case, when we have this condition, we can say that the two roots will be 0. That is, you are going to have, okay, if it's x that is your unknown, x equals to 0 twice. So the values of the quadratic roots when your b equals to 0 and what c equals to 0 will definitely be what? The root will definitely be 0 and 0. That is what? 0 twice. So you can use this to actually note at a glance what may be the value of a quadratic what equation. Of course, this is a quadratic equation. Yeah, it's still a quadratic equation, okay? The only thing is that what? Your b is 0 and your c is 0. So let me show us the third, okay? And that would definitely be the last one I will be showing you. When a equals c, okay? This is another condition. When your a is equals to what? C, we say the roots will be reciprocal of each other. The roots will be reciprocal of what? Each other. Now, how do we prove this? We know that from the product of roots that we have done, that product of roots is actually equals to c over a. So in the case when your a is actually what? Equals to your c, that is, they are of what? The same value. Okay, so put a, okay, or substitute. Let me use the word substitute. Substitute a for c. That will be alpha beta equals to, I'm substituting a for c. So instead of writing c, I will write a then over a, since both of them actually what? The same. That's since a equals to what? C. So alpha beta will now be equals to what? 1. So in this case, your alpha is actually 1 over beta. And in this case also, your beta is also 1 over alpha. So what are we saying indirectly? What we are saying is that when you observe that the value of A is equal to C, just know that what the roots will be reciprocal of each other. That is, if one of them is 3, the other will definitely be 1 over 3. Okay? So 1 over alpha will give you what? Beta, and 1 over what? Beta will give you what? Alpha. So these are some clues that can actually help you predict the values of the quadratic what? Roots. And I hope you have learned something in today's class. Please do share out this video with other students around you. Subscribe to this channel if you have not done so, and hit on the notification bell. I will need your feedback in the comment section. Let me know how well you understand this. Give me thumbs up by liking this video. God bless you, and I wish you all the very best in your studies. Bye for now.